Dear students, welcome to the knowledge series on the banker's algorithm. The banker algorithm, as the name indicates, it's a resource allocations and a deadlock avoidance algorithms. And it tests the safety of simulating the allocations of a predetermined amount of resources. That means this particular algorithm is basically used for the deadlock situations and how it has to avoid it. As the certain terminology which is being mentioned here, the algorithm can be used in a banking system to ensure that the bank never allocate all its available cash such that it can no longer satisfy the need of all its customers. That means the allocations cannot be made to all the resources, so that the situations of the deadlock may arise. The algorithm is applicable to a systems with multiple instances of each resource type. When a new process enters into a system, it must declare the maximum number of instances of each resources. This number may not exceed the total number of resources in the instance. Several data structures must be maintained to implement the banker's algorithms. Now, what exactly the instances is that? Now, here if you see that there are three different allocations, A, B, and C. So, so in the case of A cases, we can have a maximum of 7, and in the case of a B we have a maximum of a 2, and in the case of a C we are having a maximum of a 5. That means 3 resources is being given, and it has having a different possibilities being assigned. So based on this particular distributions, the algorithm is being defined. Now, in the case of a deadlock algorithm, there are certain terminology like available, maximum, and allocations, and the need, available, allocations, and maximum. These are the main attribute that is being used. So a particular process is being shown over here, and the individual allocations is being shown. A, B, C is there. So if a process P0 has been allocated with this process, the maximum allocations can be possible with the process A is defined in this particular column, B is been defined in this column, C is been defined in this column. Now the remaining needs is being determined based on maximum allocations minus the allocation resources that we are determining. Now in this case, these numbers, it is not being shown, the whatever is shown over here is not being been actually exist. The 332, that is the 3 is the current available resources, or we can say that the available resources is being shown as a 332. From 332 available resources, we have to determine these values, and for determining this value, we are always comparing with the remaining needs, that is the need with the available, and need is compared with the available. If the need is less than the available, then we can able to use the allocation resources. But if the need is exceeding that particular available resources, then we declare that it is the particular condition is not satisfied, and other condition is satisfied. So if the need is less than the current available, that is the current available resources, then the work is equal to work plus allocations. That means the current whatever is the work, that work is added with the allocations. So that is what it is. So when we are taking a first resource, say P0, in the case of a first resource of P0, the first case is we are giving that 743 is the needs. 743 is the needs. So 743 is compared with 332. When the 743 is compared with the if the 743 is less than 332, the integer bytes 7 is compared with 3, 4 is compared with 3, 3 is compared with. So you find that this is greater than this one. So this is not satisfied the conditions. Now the next is that we go to the next needs. So 122. 122 is again compared with 332. So when 122 is compared with 332, we find that this condition satisfied. So the P1 resources is 200. So work is equal to the current available resources. The current available resources is added to the allocations. That is, P1 is given with respect to the need is 200. So the since 122 is compared with this one, so available resources 200 is taken. So 200 is added with 332. The next is going to 600. So 600 because this condition is, so 600 is compared with 532. So this is not satisfied. Then we go with the next one is the 211 is compared with 532. So 600 is compared with 532. So it is not, this condition is not satisfied. So 211 is compared with 532. So this condition satisfied. If this condition is satisfied, so P3 condition is there. So P3 condition is the case with respect to 211. So this 211 is added to the 532. 532 is this thing, that thing, but the current available resources. So it is become 743. So 743 is occupied these positions. The next. Now the 531 is compared with 743. So 531 is compared with 743 and this condition is satisfied. So 743 is added with the resources of 531, that is P4002. So when 002 it has become 745. So 745 is occupying these positions. Now 743 is compared with 745. 743 is compared to 745 and that is condition satisfied. If that condition satisfied, so P0 that is 010 is added to 743. That is P01 is added with 755. 745. 745. 745 is added to that one. So 745 is added to the 010, so 755. Now once the 755 is being mentioned here, now the next resources is that 743 is over, 122 is over, 211 is over, 531. So this was left behind. So 600 is compared with 755. So 600 satisfied. So 600 having a allocation resources with respect to P2 is 302. So added is, it becomes the total is 1057. So what is the current save sequence? Current save sequence is P0, P1, P2, P3, P4 and P0 and P2. So P1, P3, P4, P0 and P2, where the P2 is being discarded. So this is the conditions with respect to the deadlock situations overcome based on the banker's algorithms. Hence the banker algorithms is a deadlock avoidance algorithms. So this is one of the important numerical problem that appears in the university question papers. What you can do is that you can change these values, you can change this value and try to solve this example by putting a new value on this one and identify these particular sections and find out what is the process order. Thereby we can avoid the deadlock avoidance. Thank you.